In this video, we're going to be talking about how to calculate the length of a line segment, which basically means on a Cartesian plane, if you're given 2 points, we're going to be required to be able to calculate the length between those 2 points, right? So let's just jump straight into it, right? So let's just say you have a Cartesian plane. So which means you have a y-axis, right? So this is your y, and then you have an x-axis. Right, so that's our x. Okay, and you are given 2 points, right? So we're going to make those points, we're going to name them generically, which basically means if this is my starting point, we're going to call this x1, y1, right? And this is our finishing point, we're going to call this x2, y2, right? And essentially, in this section, we're going to be required to calculate the distance connecting these 2 points. Right, so if you know the x's, the x and y of this point, the x and y of that point, how do we calculate the distance that connects those 2 points? Right, now in order for us to do that, we are going to we're going to turn this into a triangle. How do we do that, right? This requires us to understand the fact that in order for us to go from point 1 to point 2, yes, we're moving straight up, right? But you can think about it as you're moving horizontally at the same time that you're moving vertically. So the question is, how much have you moved in the x direction at the same time that you're moving in the y direction? Right, so you've moved in the x direction and then you've also simultaneously moved in the y direction in order for you to go from point 1 to point 2, right? Now you can tell, okay, now we have a right angle triangle. Now, why is this important? The reason why it's important is because, let's just turn this back into that. If we have a triangle, let me just redraw this, right? In order for me to find, because remember, the ultimate goal here is to find this value over here. This is the value that we're trying to look for. And if we have a right angle triangle, and the reason why it's a right angle triangle is because this was x-axis movement. This is movement in the x-axis direction. This is movement in the y direction. This is horizontal. This is vertical. Horizontal is always going to be at 90 degrees to the vertical direction, right? So we know that this is a right angle triangle. So if I have right angle triangle, all I need to then ask myself is, okay, what is this distance over here? What's this distance over there? And then we can use Pythagoras theorem to measure, to calculate what the hypotenuse is, or what r is, the distance between the 2 points. So now, what is that horizontal line and what's the vertical line? The horizontal line, remember we said that's the movement in the x direction. We're saying how much did it move in the x direction to go from its starting point to its finishing point. So let's just again trace these. So in the x direction, it started off at this point over there, which is x is equal to something. And then it finished off at this point over there, which is x is equal to something else. Same thing with the y's. This is its starting y value. This is its finishing y value. Okay, so let's just label these a little bit. So this value, sorry about that. Okay. So this value is x1, this value is x2. So in order for us to find this distance over here, what we just need to do is calculate the difference between those two. So that's going to be x2 minus x1. Same thing with the y's, right? So if this is my starting point, which is y1, this is my finishing point, which is y2. In order for me to find this distance over here, right, I will just subtract those two y values. So that's going to be y2 minus y1. So now, in order for us to find, because remember, Pythagoras theorem says, if this is my a and this is my b, right, in order for me to find r squared, I would take a squared plus b squared. So now, which can also be written as r is equal to the square root of a squared plus b squared. So what are our a and b's in this case? The a is the x movement, which is going to be the difference between your x's squared, right? Plus The b is the difference between your y's, right? That's y2 minus y1 squared. And this essentially, let's just make this a little bit prettier. This essentially is the formula that we need to know to calculate the length of a line segment. You find the difference in your x's, the difference in your y's, and then you square them and then you root the sum of those two numbers. Okay, so this looks a little bit complicated, right? So maybe let's just use a couple of examples just to become familiar with the formula and just to show that it's not as bad as it looks, right? So we're going to talk through one example, or this is going to be the first example that we're going to talk through. So let's say, for instance, we're going to draw a Cartesian plane again. All right. Our first Cartesian plane, our first direction is y. Our second direction is x. Right? We have 2 points. Our 2 points, the starting point is going to be 1 and 2, which is somewhere here. 1 and 2. Our finishing point, maybe let's just draw it somewhere here. It's 5 and 5. Right? So we're trying to draw the distance between these 2 points. Okay, now how do we do that, right? So we said our r is the square root of, so you can just plug it into the equation, right? So we said the square root of x2 minus x1 squared plus y2 minus y1 squared. And we find the square root of this value. So we know that this is the formula that we have to use. But why, right? Let's talk about the reason why. So in this case, we're saying there's movement in the x direction. There's movement in the y direction. Okay, and this is 90 degrees. So we're saying this side over here is y2 minus y1, which is, because remember this value over here, this y value over here is 5. This y value over here is 2, which means y2 minus y1 is 5 minus 2, right? Again, the question that we're trying to ask is, how much did it move in the vertical direction? In the vertical direction, if its finishing point was 5 and its starting point was 2, that means to get this length of the line, which answers that question of how much did it move in the y direction, we say 5 minus 2, which gives us 3. Same thing with the x. It started off at x is equal to 1. It finishes off at x is equal to 5. So how much did it move in the x direction? You get x2 minus x1, which is equal to 5 minus 1. That's equal to 4. So that's what we're doing when we're plugging it into this formula. We're saying, okay, we take the difference in the x's, which is 5 minus 1, and we square that. That's the length of one side. And then we take the difference in the y's, which is 5 minus 2. We square that. And then we find the square root of that answer. Okay, so that's going to be equal to square root of your x, the x side, or your a, which is 4. So that's 4 squared, plus this side, which is 3 squared. So that means your r is equal to, if you put this into your calculator, you should get 5. Anytime you square root, the answer is the positive and the negative. But in this case, since we're looking for distance, your r can't be negative in this case. So this is 5. I hope this is making sense. I know there's a lot of numbers being thrown around, but hopefully this makes sense. So let's just jump into a couple more examples that we're going to go through a little bit quicker, right? So we get a second example. So let's just say in this case, I just tell you, so we're not going to draw a graph in this case, right? We have point -4 and 2. And then we also have point 4 and -2, right? So in this case, all we're just going to do is, okay, we're going to say r is equal to the square root of the difference in your x's, right? Which actually, let me just also make a point over here. It also doesn't matter which one you start off with, as even if you say 5 minus 1 or 1 minus 5, because you're squaring it, it's always going to give you the same answer. So 5 minus 1 is 4. 4 squared is 16. If you had done it the opposite way and said 1 minus 5, it would have been -4. And if you square -4, especially, it depends on your calculator, but if you say -4 squared, because you're squaring both the -4 the negative and the 4, you're always going to get positive 16. But be careful with this. Depending on your calculator, if you say negative 4 squared, it might just square the 4 and not the negative. Just make sure that your answer over here is positive. This value is positive because you're looking at distance, right? So just something to note. Okay, so we don't actually need to draw the graph. We just need to know, okay, what's our x1, what's our x2, what's our y1, what's our y2. So we can make this x1, make this x2, right? But it doesn't matter the order. You can make, you can reverse it. You can make this x1, you can make this x2, make this x1. It doesn't really matter because as we saw, once you subtract them, you're going to square it anyway. So whichever one you start with doesn't really matter. It's not the same as gradient. With gradient, it mattered which one you started with. Okay. So now we're going to make this y1. We're going to make that y2. So when we put it into the equation, which is going to be x2 minus x1 squared plus y2 minus y1 squared, that's going to be r is equal to the square root of 4 minus negative 4. It's just that there's not too many brackets. I'm just going to write it like that. Plus the y's are negative 2 minus 2. You square that. Okay. I would just throw that into my calculator for the square root of 4 minus 4 squared plus negative 2 minus 2. Make sure that is in brackets. Square this, 4 root 5. That is your answer. Right, now let's interpret again what we're doing here. Right, we say, okay, negative 4 minus 4 gives you 4 minus 4 is 4 plus 4, which is 8 squared. And then over here as well, negative 2 minus 2, this gives you 4, or at least negative 4 squared. Okay, what we're basically saying is this, right? We are saying we have a triangle, we have a starting point, we have a finishing point. I'm just assuming that this is what it looks like. You don't really need to know, kind of exactly what direction it went as long as you use the formula correctly. What we're saying is, okay, we have the movement in the x direction was you start off at negative 4 and then you go to positive 4. That means the difference between those two is going to be 8. Same thing over here. We have 2 and negative. You start off at 2, you go to negative 2. You've moved down because you go to 0. You move down to 0, which means you've moved 2 units, but you still need to move 2 more units to get to negative 2. So it means the movement that you've moved is 4, right? This is why the direction doesn't matter. The direction only tells us that, okay, we're moving downwards, right? Which, as far as the distance is concerned, doesn't really matter. So when we square it, the square takes care of, like, did you move up? Did you move down? It doesn't really matter. All we need to know is we moved 8 units in the x direction, 4 units in the y direction. So what's this r? The r would be the square root of 8 squared plus 4 squared. Okay, hopefully that makes sense. All right, so your answer still is 4 root 5. Now, we're going to go to a third example, right? Now, this example is going to be a little bit trickier, right? Essentially, what this example says is we have a starting point. Our starting point is called x minus 10. This is the x value. And then we also have x minus 15, sorry. Those are 2 coordinates. So this is your x coordinate, that is your y coordinate. X is an unknown value, right? And then we have the second coordinate is going to be 2x minus 6 and 2x minus 15. You're also told in this question that the length of the line between these 2 points is 2x minus 4. So you need to calculate the x value. Okay. How do we do this, right? So, okay, cool. All we need to do is say, okay, we have a formula. Our formula tells us that r squared is equal to the square root of the difference between your x's, so x2 minus x1 squared, plus the difference between your y's, y2 minus y1 squared. Okay? So we need to figure out what the x2 is, what the y2, x1, x2. So this is going to be our x1. This is going to be our y1. This is going to be our x2. This is going to be our y2. So now we can just plug them into the equation. Also, this is going to be our r, because that's the length of the line. So what we'll do is we'll say, okay, if our r is 2x minus 4, we're squaring this because it's r squared. That's equal to the square root of, actually, it's not supposed to be square root here because the squared is on this side. So remove that square root. Okay, so that's x2 minus x1. So now what's x2 minus x1? We're going to draw big brackets over here. x2 is 2x minus 6. Subtract x1, which is x minus 10. And you're going to square this. This looks very complicated, but it's going to get easier along the way, hopefully. And then same thing with the y2 minus y1. So we're going to have 2x minus 15 minus this y, which is x minus 15. Just be careful to put the whole thing in brackets because you're subtracting this entire thing, right? So just make sure that the whole thing is in brackets. So now we just need to simplify this expression, right? So 2x, I'm just going to do this very quickly, all right? So if you're squaring this bracket, you square the 2x, which gives you 4x squared. You say 2x multiplied by negative 4, which gives you negative 8. Negative 8 times 2 gives you negative 16x. Negative 4 squared is positive 16. That's that side. On this side, we're just going to simplify inside this bracket first. So we have 2x minus 6. This negative is going to multiply this, and it's going to multiply that. So it gives you negative x, and then negative times negative 10 gives you positive 10. We're going to square that. Plus, same thing here, 2x minus 15. The negative multiplies into the bracket, so that gives you negative x times positive 15. We're going to square this. All right? And then over here we have 2x minus x. We're grouping like terms, right? So this is grouped with that. So we have 2x minus x, which gives you x. Negative 6 plus 10, that's the same as 10 minus 6, which gives you positive 4. And we're squaring that. Plus 2x minus x gives you x. Negative 15 plus 15 gives you 0. So that's just going to leave x over there, which is very convenient. That's 4x squared minus 16x plus 16. So now we are going to simplify the right-hand side like we did with the left-hand side. Square this, right? In order to square it, we say, okay, what's x times x, which is x squared? Remember, we said we're doing this a little bit quickly just because the video is already too long. X times 4 is 4x. Multiply that by 2 gives you positive 8x. You can always just, do the FOIL method if this is confusing. And then 4 squared is 16. And then you add x squared. Again, we're going to group our like terms. So this and this are going to give you 2x plus 8x plus 16 is 4x squared minus 16x plus 16. Now, because it's a quadratic, right, this is turning into a mess. We need to, this is supposed to be squared. We need to make sure that all the terms are on one side. So we're going to move everything to the right-hand side. So we're going to have 4x squared minus 2x squared. And then over here, we still have the negative 16x, but now we're moving this 8, which means it becomes negative 8x. And then we still have positive 16 over here, but now we're moving this positive 16, which means it becomes negative 16. That's equal to 0. All right, simplify. So 4x squared minus 2x squared gives you 2x squared. Negative 16 minus 8 gives you negative 24x. The good thing is that these two are going to cancel. So that actually makes our solution look a little bit cleaner because now all we have is two x terms. We have an x squared and an x. How do we solve this? We can solve this by factoring out an x value. That's going to leave 2x over here minus 24. That's equal to 0, which means we have two solutions. The first solution, because we have two brackets multiplying by each other, we factorized. The first solution is the solution when this first bracket is 0, so x is equal to 0, right? Now the question is, can x be equal to 0? If x is equal to 0, this means this term over here becomes 0 minus 10, which should be fine, actually. 2x minus 4 means 0 minus 4. Your length can't be negative 4, so it means your x can't be equal to 0. But the second solution is 2x minus 24, which is equal to 0. So your 2x is equal to 24, because you moved the 24 to the other side. Divide both sides by 2, so you get x is equal to 12. Right, now let's see if that one works, right? So if x is equal to 12, this means this x value is going to be 12 minus 10, which is 2. This one becomes 12 minus 15, which is negative 3. This becomes 2 times 12, which is 24, minus 6, this is 18. 24 minus 15 is 9. And then this length is 2 times x, which is 2 times 12. I'm losing track of the numbers. 2 times 12, which is 24, minus 4, that gives you an R of 20. So this works. So this is fine. Remember, you can't, a common mistake is at this point to divide everything by x. The moment you divide by x, you're losing this solution, which you're going to get marked down for. So just be careful about that when you are solving problems like this. But that was a bit of a long example, like a little bit more complex example as to how you might be asked to calculate the length of a line. All right, but we'll do more questions. We'll do more past paper questions a little bit further along the way. But for now, I know this was a long video, but I hope this was helpful. I'll see you in the next one.